My dear participants and today's resource person Bhavana ma'am, a very good morning to everyone and welcome to online faculty development program on artificial intelligence, machine learning and data science with research application. I have great privilege to read today's resource person Dr. Bhavana Rudra ma'am profile. Dr. Bhavana Rudra is currently working as Assistant Professor, Department of Information Technology, National Institute of Technology, Karnataka, Surathkal, India. She has completed her PhD from Indian Institute of Information Technology, Allahabad, Uttar Pradesh, India in 2015. Her research interests include blockchain, quantum cryptography, information security, network security, future internet architecture security, Internet of Things. She has published more than 20 publications, including 10 international journals, 15 international conferences, and book chapters in IET, Elsevier, Springer, IGI publishers, etc. She is the technical reviewer for various international SCI index journals of repute like IEEE, Computer Society, Elsevier, Springer, etc. Now I request Bhavana Rudra ma'am to take over this session.
Yeah, thank you, ma'am. Thank you for the short intro. The papers have increased now. It is around 70 plus. Okay. The total journal and research papers. And there are some four projects with respect to the quantum machine learning. Yours is artificial intelligence. The advanced topic is quantum machine learning, quantum deep learning. So there are four different projects which I'm into it. So along with they are sponsored by Mighty, DRDO, and TIH, Vilai, and so on and so forth. Some are from the consultancy also. So it includes all these things. So this is just to give an overview to the reviewers, like why I'm into this area, although you have mentioned I'm expert in security. So as I am into the quantum machine learning and deep learning, so for that reason, I agreed to take this session. Okay. Yeah, this is about brief intro about me. Can I share my screen now? Is it? Please allow me.
Yeah, ma'am, it's allowed.
I guess PPT is visible. Yeah,
Yeah,
can
ma'am.
you please let me know if I'm changing the PPT, whether it is changed or not?
Yes, ma'am.
Yeah. Okay then. Okay. Today, everybody might have discussed about ML algorithms, DL algorithms, your CNN techniques, and so on and so forth. But people might not have discussed the advanced topics where you can combine your ML algorithms with optimization techniques. So that what are the various optimization techniques that we will see today, so that you will able to understand in order to make your algorithms work in appropriate manner. I mean, to give you the faster outputs, performance properly, up to accuracy, whichever parameters you are actually considering in into a highest point, like accuracy, precision, recall. So F1 score, all these things, parameters matters a value for your research work or for your experiments which you are doing. Those are the parameters will give you the entire information about your experiment, right? So for that, in order to improve the accuracy, improve the F1 score and all, we can go with adoption of optimization algorithms where you can combine with your other algorithms and come up with the hybrid models. So for that reason, in order to understand it, first let us see what do you mean by optimization and where we will apply and when to apply. So in this scenario, I can say it is based on some conditions on what we are going to derive maximum or minimum value of a quantity in terms of quantity or revenue. So the best example I can consider is your traffic. So in order to reach from X to Y point, if there is a traffic jam and if your time is more important, that is you have to reach as early as possible, then definitely you will go opt for a lowest, smallest path, And even if traffic jam is there, you will try to figure it out how to reach to the uh, point in a very quicker fashion. So for that reason, you are going to adopt this kind of method. There, unconsciously, your mind or your time, based on your time, your conscious mind will work on it, saying that no, no, instead of taking this route, we will take this route. Many are adopting this kind of route. Let us adopt the same route so that we may reach to the destination in a fastest manner. So that is how things are going on. So indirectly, we adopt these techniques in our day-to-day life based on the constraints, based on the objectives, based on the design and decisions which we are actually considering. So in short, I can say it should contain an objective function, that is your whether, I mean, to reach your destination, whatever you want to say, from X to Y, and variables which are known. So the moment if you have seen the traffic over there, immediately you are deviating your vehicle to move towards the other path. Those are the design or decision variables based on the surroundings you are taking sometime, and sometimes you are taking it based on the knowledge. Sometimes it is unknown, sometimes it is known. Those we call them as design variables. And the constraints, that is conditions. If time is not important, you can stay there for longer time, then it is fine for you. But if at all time is a major constraint, then definitely you are going to go fast. So that is how things will go. So these are the main components for the any optimization problem which we are going to consider. That is the objective function, variable, and the constraints. So the problems that can be solved using your optimization techniques are scheduling problems, network design problems, facility location problems, inventory transport. So the facility, inventory, transportation are almost equal with the priority which one you are going to see. So facility location is nothing but where you want to go exactly. That location is the possible way it shows to you. Okay, inventory is nothing but the tracking of the managed of the entire goods and services. Although all these three uses the transportation, all these three uses you entire GPS, only one GPS process. Okay, but still, although it uses GPS, but these three are different. So facility, the moment when you search, I want to go from X position to Y position, it will try to give a appropriate location for you. Transportation problems, if you see your traffic jam, immediately alerts will be given to you in the in your GPS whenever you are going to start it, right? So inventory, it is nothing but the tracking system where you can say that from the goods from X to Y, whenever it is going to go, need to be tracked. Next comes your minimum spanning tree problem, shortest path problems, maximum flow problems, min cost flow problems, minimum cost flow problems. So those are the various. I hope you all, I mean, as you all are faculty, so you might have come across all these problems. In the subjects also, you might have you might have taught the students also. Still, you're teaching also as of now. So these are the things which you know all about it. So I'm not going in detail. So let's see the optimization methods in detail. What are the algorithms that are existing as of now to solve all that such kind of problems? So when we see the entire modeling of the optimization process, in say there is a real-time problem, you are going to have some assumptions, some abstractions, some data, and some simplifications based on which you are going to have a mathematical model, and using those mathematical model you are going to come to a conclusion or a solution, mathematical solution. Then you are going to interpret, or when you are going to write a code in order to get the solution. I mean, whether it is matching with the real world or not, that testing part you are going to do, whether it is making any sense or not. This is the common, even if I remove the optimization model, if I replace with ML model, same thing you are going to do. Whichever problem, whichever data set you are going to consider, same thing you are going to do. But in the MLDL, I mean, generally we say that the mathematical models are inbuilt. So whatever algorithm you want, you are going to just pick it up from there. Over here also you have the optimization algorithms, which you are going to pick it up based on your three main points, that is your objective, or your constraints, and your variables. Okay. So there are types of optimization models. So if you see, stochastic models are there based on the probabilistic information, deterministic models based on where the data is certain. In the deterministic model, you have integer based, discrete based, and continuous models. Where the data is continuous, for example, I can consider stock data for the continuous. Discrete integer, you can go with some text, test data. So the DOS attack or so on and so forth, if you are just based on the previous history, if you are going to continue, take the data, then you are going to test it on and come up with the model. If it is dynamic model, then you are going to have a continuous data, it is going to test. And based on this, you can have a linear and non-linear entire solutions based on those. So when you go with the classical optimization, I can say you are going to find the optimum solution on an unconstrained maxima or minima, which is of continuous and differentiable functions. It varies. So if you are considering a static data of continuous text data or so on and so forth with a lot of conditions and variables, then we say it functions in a different way. It is not a continuous data. So for the prediction, once you have deployed it on any particular system in order to record it, then we say it is a continuous data. Continuous functions it has to consider, and then it has to give you the proper predictions. So analytical methods make use of differential calculus in locating the optimal solution. We have the limited practical applications with the which are not continuous and differentiable. So actually, whatever data we are going to consider, we are actually making it like, for example, stock itself. We are saying that last 50 days stock information which we are considering, and we are coming up with this. But last 50 days you are experimenting. What about 2 days? What about tomorrow's? So those predictions which you are saying, so the maximum of the data will be of a sometimes for the stock it is continuous. Even for the stock also, based on the stock, which company stocks you are considering, that also varies, which will give you the non-continuous data or uncontinuous data. So we can say it as a continuous data until unless it will be giving on a daily basis, on an hourly basis, even chemical factories where the sensors will detect continuous for a detection of your gas leakage or so. So the moment, so it stops, it routine. As a routine, if there is no gas leakage, it will not detect anything. So routine, it will go. The moment it detects, so the immediately it alarms. So that becomes the non-continuous or uncontinuous data. So, I mean, based on which you have already trained based on the continuous data, and you are well trained, well equipped, and you are saying that based on this particular scenario only, it has to alert. So basis for developing most of the numerical techniques involved from the advanced methods. So these are the three types of problems that can be handled using your single variable functions, multivariable functions with no constraints, and multiple functions with both equality and inequality constraints. So when we see the problems with respect to equality constraint, then we use the Lagrange multiplier method. And for the inequality constraints, Kuhn-Tucker's conditions will be applied in order to get an appropriate optimum solution. Okay. So there are the other ones. One is the classical, the other one is the numerical methods, where you are going to have a linear programs, which consists of the objective function, which is a linear function, and a set of design variables space which is being specified using the special linear equalities or inequalities. So based on those functions, you are going to consider the conditions, and based on that you are going to derive the solution for the linear program. For non-linear, objective function exists with some constraints in a non-linear parts. So you can consider the convex problems where it does not give you any linear parts. So generally it is very hard problems, so not guaranteed to find the global optimum solution. So minimal optimal solution, local optimal solutions are easy to derive using your non-linear program functions. But whereas if you want to go with global optimum solution, then you have to have a linear program. This is like your, you can link this with your data sets so that it is easy for you to understand. So next comes your integer programs, where it says that it should have the linear programs along with some constraints. So all the linear programs which has its own set of constraints with the integer values, we call them as integer program. Next comes your quadratic programs, where it has the quadratic terms. So with the set A, set B, and with linear equalities and non-equal inequalities. So based on nature of these equations, it has been divided into linear programming problem, quadratic problems, non-linear programming problems. So where these equations involved, and based on the permissible, then we say them as integer programming, real valued programming, or which are based on the decision variables. Okay, which allow only the integers to take as a input and gives you a appropriate decision based on real values or real integer values. Okay. So in that category, we can say that integer programming and real valued programming falls into it. Based on the number of objective functions, where you are going to define the objective main decision based on, you are not going to decide which constraints you are considering. Here, the main objective is your criteria. For example, for this, I can give the first one is your traffic example, and second example, I can say you have multiple tasks. Okay, in between, in order to go to supermarket, in between you need to meet your friend as well. So that particular time you will decide in such a manner when you start from house. So you will fix it in such a manner saying that I have to reach, I have a stop in between. So my targets are 2 targets, more than 1 target. So I'm actually have a stop in between, then I'll finish that work, then I'll reach to the destination, then come back to the source again, back to source. So in this way, how many objective functions you are considering, based on that, we are going to derive the global maxima or global minima based on the objective function. In the single function, definitely here also minimum and maximum global functions will be considered, but this is for only one object, single object, not more than that. So that is how the objective, based on the number of objective functions also, your algorithms will vary. So there are other programmings which are existing programming problems which we can assign. That is stochastic, which is based on the constraints, totally depends on the random variables, and dynamic program, which is based on splitting the problem into smaller sub-problems. So by the traditional type, I can say this, there are unconstrained optimization algorithm and constrained optimization algorithms. So over here, if you see the unconstrained algorithms, optimization algorithms, line search method, trusting region-based methods, so tensor-based methods, homotopy-based methods, these all fall into non-linear equations, where you have to take a decisions based on that particular environment. There is no global and when you go with truncated Newton methods, difference approximations, quasi-Newton methods, non-linear conjugates, non-linear conjugate, non-linear complex, simplex method, Gauss Newton methods, linear. So these are the least square methods which you are going to adopt, which fall into non-constraint optimization. When you go with the constraint optimization, there are bound constraint optimization algorithms, linear programming algorithms, quadratic programming algorithms, and it's a set of quadratic algorithms where algorithms for the quadratic programming is different, and quadratic programming based algorithms which are already based on the feasibilities and all, those are different. So if you see semi-infinite programming programs are also available. So these all algorithms are actually available for you to directly use in using the libraries. Okay, but the background of these algorithms we are actually not considering. We see the functions based on our constraints, whichever we want. Based on previous slides, which have that object always which whether it is a single function, single decision objective function, or a multiple decision function. Based on those functionalities, your algorithms will be decided in order to adopt in real time. So how you are obtaining to that particular, by how you are retrieving a solution by achieving your requirement, whether it is maxima or whether it is minima, global optima, or local minima, local optima. Based on that, you are going to adopt the algorithms. So Newton methods, which are actually bounded to a constraints. So it is based on the constraints, gradient projection, and Newton methods. So once your constraints are clear to you, that is what are the conditions, how you are using the variables and constraints are clear to you, then based on that you can adopt these two methods. Again, these all have its own algorithms. You can go through in detail set of algorithms for each set of these optimization techniques. So linear programming, simplex and interior point methods, algorithms of for the quadratic programming, where you have even augmented Lagrangian methods, reduced gradient, sequential quadratic programming, feasible sequential quadratic programming, and so on, so forth. If you see KKT reduction method, semi-infinite programming, this kind of semi-infinite programming will be adopted where you are going to have a partial solution that gives you a partial solution and you are okay with it. So the algorithms, when we are going to discuss, I'm going to let you know where you are going to get these kind of solutions. Okay. So central cutting plane methods, discretization methods, KKT reduction methods, and SQP reduction methods. These are some of the algorithms which are actually exist. So now we are actually entering into the main part of it in detail study, where we say that these are the various algorithms which are available, and these swarm intelligence based algorithm, bio-inspired based algorithm, physical and chemistry based algorithms. So in this all algorithms, we are going to discuss bio-inspired and swarm algorithm, so that it is, it is very much aligned with your I can say with your MLDL, where the people will adopt a lot of things into it. So that we will discuss in detail one by one when we go. So in those things also, you have based on these two categories, we have evolutionary algorithm, trajectory based methods, hill climbing, particle swarm, pattern search, ant colony, taboo search, fuzzy optimization. So these algorithms are the main algorithms for all your experiments to do. So that is the reason I'm covering these algorithms today for your session. The previous set of algorithms based on what I have shown, that you can go through based on your requirement. Okay. So next comes your genetic algorithm, first one. So which has been introduced by John Holland in 1970s. Over here, he is considering the chromosome with a string where he is going to derive the gene of that, and he is going to say that the it has three parts. One is genes, second one is locus, and third one is the value of that particular gene which has been selected. Okay, so it is a strong tool with adaptive heuristic search algorithms based on the evolutionary idea. It is more to facilitate a more robust algorithm where it can give you the output in a appropriate manner, where your main goal is to achieve in order to differentiate and achieve what which value and which is your exact dividing the text data set or your image data set into a part of it. I can say text data set is much too, I mean, over here, which has been considered. So there they are going to derive what kind of bit it has, where exactly we need to locate that bit, and what is it locus, that is location of that particular bit, and what is that value of that particular bit in the entire scenario. It is like identifying the genes of the current whatever we say, our own genes. So it is like when we take the blood, they won't able to identify immediately. Especially they have to go with the genetic operators where they are going to derive that particular type of the gene which based on which they are going to conduct the crossovers and mutations. They will do some experiments on that, which is for example, even if you have an allergy, for example, continuously, then they take that blood of yours and they start injecting the various kinds of algae to it, and they are going to test it in order to which exactly which antibiotics is suitable for you. So where it is going to test it and where it is going to check saying that yes, this part or this kind of antibiotic is suitable for this kind of person. So not only for genes testing, even for this crossovers and mutations and all also can be performed. This is called mutation, where they are going to make it, I can say, artificially they are going to test it. They are going to expose that to the sunlight and moonlight, whatever they want to do the test in the laboratory. And ultimately, they will give you the appropriate result based on whatever your requirement. So I can say though based on that organisms offsprings will be derived, and based on those things the crossovers and mutations will be performed. And there are a lot of types of mutations which will be performed. If you see over here, relocation of the genetic material, translocations from one chromosome to the other, wild type of sequences where they can delete, they can missing, they can find out the missing chromosomes or extra chromosomes or duplication of those and inversions of those and gain of that exact material. So they do a lot of mutations over there. Similar fashion on your data set, let it be image or text, I'm not interested to know that. I'm just considering a data set where they are going to have this kind of experiments to be performed using this algorithm, and they are going to derive the conclusion. So if you see that deriving the conclusion is nothing but the fitness value. Okay, so if I say what is the fitness value where the gene is getting or the when it has been mutated, where it can sustain with that particular antibiotic. Okay, that is the fitness function. So from the overall population, the initial population will be generated. That is the from your entire blood, whatever. For the experiment, they are going to derive. I'm considering, I'm saying your blood, because one day or the other time you might have given your blood for the mutation purpose in order to identify which kind of infection is there and how it rotates and mutates and come, and they give you based on that antibiotics. So for that reason, sorry for if I'm annoying anyone. And it comes in such a manner. First, they are going to generate the initial population. This is with respect to the algorithm where your data set is there. You are going to generate some initial population based on that. So, and then you are going to evaluate the fitness function, then meet a optimization criteria, where you are going to say that the minimum problem number of conversations which can be done, and we can derive a optimum solution based on that exponential function. So based on that function, so then once you receive the optimization criteria, then you are going to stop the function. That is which bacteria is against to that antibiotics, which is functioning properly for that particular bacteria. It is sustaining more and more. So those things falls into the optimization criteria. Once they figure it out, then the function will be stopped. If not, then the selection process will go on. They are going to regenerate the process again from the initial population. They are going to again evaluate the fitness function. So this genetic algorithm has come as this process looks very similar to uh, the process which actually happens in the bio-inspired biomedical industry. Okay, so for that reason only it has come, because that process is very common for them in day-to-day process which they do. But in the computer science we don't have as such. So for that reason this has come into picture, saying that same thing you can apply for your data sets also in order to get the local and global maxima. So simulated annealing is one of the other process where I can say that based on the state, it is going to be derived. So this has been derived from the metallurgy, where the annealing process will go in that way, they are going to perform. Here, the once you are going to get the global optimum solution for a given objective function, then we are going to fix it off that yes, this is the global optima. Based on this temperature, the entire system need to be controlled. So based on that, even for the servers which we are going to install, we'll say that on what basis they have derived that your entire lab should be at 25 degrees below. If there are a lot of servers altogether, then cooling point will be fixed, right? So that is nothing but based on this simulated annealing process. So the entire global maxima will be derived. So wherever they are going to supply that particular servers to the any places, so there they will be setting the temperature, saying that this is how it has to function. This I'm actually discussing with the local example and then showing you the entire algorithm so that it is easy to understand. And based on the states and changes, yes, definitely from location to location again, the temperatures will vary. Even if outside temperature is 8 degrees and again you are supplying 25 degrees in the lab, it does not make any sense for the servers. I'm talking about the servers, not about the humans. So it does not make any sense. So the global maxima will be derived based on the neighborhood solutions. How the neighborhood based on that part, so they are going to derive. So this is the comparison and gives you the entire solution. If you see the algorithm for a simple temperature based work, so if you see then the temperature, so the energy estimation will go with this kind of algorithms where it is easy to understand, easy to derive. Okay, so the initial temperature if we assign as T naught, then generate a trial solution in the neighborhood based on the previous and current objective functions, then calculate the trial functions and with a set, then if the set is less than 0, then you accept the trials. If it is more than that, then go with the probabilistic solution where it is going to decrease the temperature, set to accordingly, set the temperature according to the environment, then again give it back the best solution by looping into it. Next comes your hill climbing. So based on the local search and iterative algorithms, this is based on the local maxima, not the highest. You are not going for the global maxima, where your algorithms which have local information and you need to derive the local maxima, then your hill climbing is the best option to adopt. It starts with an arbitrary solution to a problem and attempts to find the better solution by incrementing by one, that is single element, or one by one, step one by one, not at a stretch. Okay, so not into yeah, not at a stretch. You're not reaching to a global maxima over here. You're going to have a local maxima. So this kind of solution will go with the algorithms where you require the, where you can give the importance to the local maxima only. So you are based on local solutions, local examples where you are actually surroundings. I can say surroundings. Based on that, you are deriving some solutions. So such kind of things are one. So we are comparing. For example, your college is comparing. Your only college is being comparing the best faculty. So that is a local maxima. It is not comparing with the other, let us say all private institutes. If they compare, then your faculty may be the medium or maybe the best faculty. But we are not going for the global faculty because the institute, whenever it gives the best faculty award, for example, so in that case, it will compare among the local people of other departments or maybe within the department. So this is not at the highest level. So over here, the plateau is your own department comparing with the other departments. Okay. So, but you are not going to have a global maxima there. It depends on how your institute is going to cover it off. Okay. The best example which you can consider. Similarly, you can have some data sets and you can compare. So it is like if you see it is a hill climbing, the examples which we have considered. So we are not reaching, we are not seeing the global maxima there. It is like you are enjoying your life within your own boundaries. So till now, I mean, almost I've covered three to four algorithms. This I'll continue. So any queries or anything so that we can have some small discussion, because even I'm new to this particular topic. I have explored, I have done some experiments, but not with all algorithms. So any queries or anybody who is working in this particular area? Out of 110 participants, no one is working in this area. Great. Okay, let me continue then in that case. Am I audible?
Yes, ma'am, you're audible.
Yeah, thank you. So hill climbing is, as I have taken the example of considering a best faculty in your institute. So look one step ahead. First, they will be seeing in your own department whether you are whether within the department who is the best faculty, who has taken a lot of courses based on your own criteria. Step by step, they will compare how many subjects they have taught, what is their expertise, how many classes they were regularly they have taken, what kind of assessment they have done with respect to the students, how much support they have given to the students, so on so forth, whatever criteria. So one by one, they are going to check. After the department level, if they have to compare institute level, then they will start comparing with the other department. So it is a step-by-step process, not at a stretch process. Okay. So in that way, I can say if you have look one step ahead, then you have a function which is greater than the previous one, then you are going to stop the process. If you don't have the function with the previous one greater, then in that case, you are going to increase one more level in order to regenerate the process. So that is nothing but I'm comparing with one faculty first in the department. So I got some information among the X and Y faculty is better. Then with that Y faculty, I'm comparing with other faculties information, and I'm retrieving whichever faculties details I'm getting higher, then I'm dropping the other faculty details, and I'm comparing with that faculty details with the other faculty details. So in that way, I can say that we are actually step by step, not at a stretch. At a stretch will be compared only when you have a lot of criteria, and all faculty, or you have taken the feedback from all the students at a stretch, saying that we are taking about with 5 faculty. So you give the voting system, or you give this feedback survey of these particular faculties. We are doing it, and you get that will fall into again the genetic algorithm, or based on your simulated annealing process. Okay. So if you are considering same faculty appraisal or best faculty award, so in these 3 scenarios, if you see, first scenario, genetic, how much genuine the faculty is there, and when you are going to compare with a group of students are giving the opinion about the faculty. So you're based on that, you are deriving some information. Okay. Not in a global way, but you gather the local information. Then you are combining with the global in order to get the global optima. Okay. So that is based on your gene information mutation. After mutation, whatever information you are going to receive, that you can consider. Then simulated annealing is based on your neighborhood information, your colleagues, what they say about you, for example. So not only the students one, we are even considering the neighborhood information in order to give a genuine award to a faculty. Okay. So this is one more level of observing the faculty. We may consider, we may not consider two levels. It depends on the requirements of the student, so on and so forth. So this is one way, and the other way is, instead of neighborhood comparing, being an HOD starts, as he knows everyone in the department, they will start comparing them among themselves by taking some survey, local, step by step. They will give one task. They will see how the all faculties are doing it. If one got higher percentage of quick answers with a higher percentage, then they will give more marks to that particular faculty. Then again, they will start comparing that particular faculty with the other department. Then general tasks. I'm not talking about specific class taking subject task, general tasks. So when they compare, when they start saying that yes, instead of X and Y has done the work properly. When they start giving combining that Y with Z. So it is one step-by-step process. If you see in day to day, whatever task or whatever we are doing it all falls into this algorithms. So that is the reason we say that these are bio-inspired algorithms. Some are from the biotechnology, some are from the local, whatever we observe, and how the humans are adopting it in day-to-day life. Okay, unknowingly or knowingly, we are actually adopting to this kind of algorithms in day-to-day life. So I hope I'm clear with all the algorithms as of now. Next comes your particle swarm intelligence. So by seeing the figures, which are images which are there in the PPT, you may observe a flock flying together. So birds flying together, a flock, we call it as a flock, right? So you can see there are randomly they are flying together, different thing. So we call them as personal best. Okay. And if they are following an order, you might have observed this thing in this sky when you go, I mean, in general way, we observe, right? In day to day also sometimes. So of bird flocks together, and they go in a random fashion all together, but they are going together only. So that we call it as personal best algorithms. And those who are flying in an order, and that we call it as global best. Okay, and even the fishes will follow the global best algorithm only. They follow the elected personnel who is the in charge for the entire flock to take to a particular place, and all will go all together. They follow a line, the order which has been assigned by the in charge. Okay, so that is how the birds will fly in the sky. So the particle swarm algorithm is a computational method to optimize the problem. It works iteratively, trying to improve the candidate solution with regard to given measure of quality. It even studies the position and velocities of a particle at a time. So now these are the some of the examples which you are getting through the images. Now, can you compare these things with your local examples? So where you require the team building, teamwork. So teamwork, you are going to select a team leader, then you are going to follow them, whatever instructions have been given in order to finish the work as quickly as the other teams. Or sometimes in a competition, the first team will get, like those who are having a proper coordination among the teams, among the group members of the team, they win the first prize. So these are the some of the examples you can consider. So how these examples can be applied? The methodology involves setting up the grids in the decision space, where it evaluates the values of the objective function at each grid point, so that it will get the optimum point at increment and decrement it, so that it can increment and decrement the grid values, so that best value of the objective function corresponds to the optimum value, which is considered to be the optimum solution. So the stages which are involved with respect to this is the patterns, meshes, pooling, and increment and decrement values. So if you can say, some kind of patterns will be observed. So you can see the best example for this you can consider as a GPS. So you have different paths to go from different places. So at that particular time, whenever you say, whenever you say, uh, so it gives you many destinations as of the consideration of the algorithm. So the meshes for each point, so that you can select the best optimal path in order to reach to the destination. So it is a pattern which followed by the GPS in order to give you this best path. So if you see that the after the main objective has been achieved, then the polls will be taken into consideration. The polling is nothing but you are going to how you are going to meet your destination point. Okay. So increment and decrement, this patterns, if you change the target will remain. If you change the route of that particular in the GPS location, if you change it, then definitely it will give you the, again, it will search for the optimal solution and it will give you the output. So that is how the pattern search will work. It search for the patterns which are available within that particular group. So if you see, this is how the patterns will be searched. So see, it is being rotated, but this pattern and this pattern is same. So that you can say that based on the local minima of the objective function using the polling functions. It uses the polling in order to achieve to the local minimum. We require at least minimum things, not the maximum things. So So for that reason, we can, if you are interested in searching the paths which can able to retrieve you some out based on that, then in that case you can adopt this kind of algorithm. So for this, the algorithm says that when you have to generate a pattern of points, both direction in terms of coordinates, especially mesh the size and center of this pattern on the current point. So if I consider this entire from this, I'm considering this. Then in that case, I'm going to fix the mesh for that particular pattern, which I need to identify in the similar patterns I need to identify in the other uh, grids. So in that case, I'm going to evaluate the fitness function. I'm going to observe the entire pattern, how it has been given and what is its measurements, whether it is aligned or whether it is squared or whatever the alignments it has been given. The pattern will be observed exactly. Then it will be searched in the, if even if it is 10 different patterns are there, I have to perform on 10 different patterns. Okay, then based on, once we evaluate the fitness function, that this is the perfect alignment and this is what we are searching, then we are going to go with the pole process, where the minimum objective of the pattern is derived from the k plus 1 point minus the current point value, so that you, in all the patterns you are going to perform this particular polling operation. If the poll operation value is less than 0, then we say the function has a double the mesh size, and we again go back to generate the pattern points. If it is poll is greater than 0, then we are going to reduce the mesh of that particular that particular grid. Then we are going to measure the mesh size again, so that once it is half, then the threshold will be reduced. So the threshold should be maximum than the mesh size. Then we will stop the process. Else we will go back to the again generating the pattern points. So if you see over here, this is what we have observed from the entire mesh process. From the grid, we have reduced that mesh, and we have observed that although it looks very similar, but it is a rotated manner. So we say that we achieved up to a certain level, but not exact match with this, as we have only two options. Instead of two, if we have 10 different grids, and then we have to match exactly, then we have to search in the 10 different grids, then you have to further proceed. So this, how you can relate this to a real example, real time example for the pattern search. So this is how you can relate to the pattern search with the example which I've discussed right now in the real time. So this is how it will get matched. So for the traffic also, for not only for the traffic which I have taken the example, but you can even consider various examples where you need to see the patterns. So sometimes we observe like some faculty among ourselves, like who are your colleagues, close colleagues. So you have seen regular fashion, they follow only one particular pattern in order to proceed for daily routine. Okay. So those patterns also you got to know that this is how they are, and what to talk to them and what not to talk to them. Based on that, how they react and all you have observed. So if you want to be the friends also in that way, I mean, not the first example which I've considered is traffic, but not only that, you can compare with all these things so that you will know the exact patterns of a person, how they behave at what time. So that is also a best example in order to make yourself involved, or in order to make yourself out of that particular loop. So in this ant colony optimization, if you see, it is almost similar to your ants, which are going to, this we might have experienced when we are kids also. Even your kids might have experienced right now. So when we draw a line in between, that is nothing but we are actually deleting the pheromone chemical which has been released by the ants. At home, it is a general pattern which we observe it day-to-day process, right? So they follow that only one path which has been actually specified by the ant. For this, they don't get into one particular path just like that. A set of ants get separated. They try to figure it out where exactly the food is there. Then they try to figure it out which is the shortest path and they start adopting. If the path is distracted by any successor or any other because of some reason or water or so on and so forth, then in that case even we remove that pheromone chemical, then it will get deviated with that path. But still, although it gets deviated, it will try to figure it out just next to that. Again, it will start aligning itself with one more chemical release. So it will try to search for the optimal path and shortest path or optimal path, and then it starts sending the food to the its own house. I can say house. Okay. So ants generally they don't go a particular path, I can say. First level, they scatter themselves, and once any group leader, the moment when they find food, then they start creating that entire path so that all will follow and food will be transferred to the ant hill. Okay, so that is how the entire process goes. This process we all know, but in real time, not only this ant colony which we have stated right now, where else we can apply in real time? What are the various examples we can apply where we can test using this ant colony optimization method? So these are the various examples, whatever I indicated just now. So these are the various examples where you can apply this ant colony optimization. If you see, then this is the algorithm. So this is the ant colony optimization algorithm. So if you can see this, you can see this. First is to select the initiator parameters. Then all the ants will schedule their own first operation, and each ant will update the list of feasibility of that particular operations. Then the pheromone evaporation will take place. Then update the probability values for each edge to feasible node. Feasible node, then we are going to perform the ant schedule its next operation. Then we are going to figure it out where the food node, major food node is existing. So based on that. So now if I say this, your data set, the possibility of your stock market data set or XYZ data set, whichever you are going to consider. So same process you can apply in order to figure it out. The various data, various company stocks you can consider, and those stocks you can get into. I mean, you can divide into different parts and in order to find the feasible operation. Then you can update the probability values of each edge to a feasible node. Then every ant will be scheduled its next operation. That is nothing but your next company updates. And once it reaches to its maxima, then you're going to have a best solution. So this is another example which we can consider in order to figure it out for the for your ant colony optimization best solution. Not only the ML and EL solutions will give you the answer, even these things also you can use it in order to get the best solution. And based on that, if you can combine with some of your algorithms and combine these optimization algorithms with your ML or DL algorithms, then you can come up with very good solutions in order to have appropriate like hybrid models, and you can even deploy them in real time. So there is a chances for you to get the more and more papers to get accepted. Next is the taboo search. Taboo search was introduced by Fred W. Glover in 1936. It is a meta-heuristic based local search methods which have been used. At each step, worsening moves can be accepted if solution gets stuck to a strict local minima. A forbidden taboo is introduced in order to discourage the entrapment of the previous strict local minima solutions. So I can say over here, it is a meta-heuristic based local search. It is almost similar to hill climbing methods, but this will be accepted only on a strict conditions. So based on those conditions, which we are going to consider, based on that particular set of solutions, which you are going to get based on the local minima and local max, those things you are going to consider as a output. So this is like a trap, I can say. You can first need to have a feasible solution, then you can have a trapped solution, optimal local trapped solution, and then you are going to figure it out the solution which has been reached or not. So initializing the entire parameters where you are having a taboo list restriction and then the aviation values. So set the iteration counter where k equals to 0 and select the initial solution x belongs to capital X, where set of x equals to the x. That set falls into that capital X itself. Then you are going to start the process based on the trial solutions, based on your entire search global optima and local optima solutions which you require for your data set. So based on that, you are going to you are going to combine the neighborhood solutions over here. You are going to figure it out the local maxima and minima solution. Then you are going to select the parameters based on that. Then you are going to set the best scheduled solution which you are going to obtain from the parameters. Okay, if I say then based on the algorithm, specifically if I talk about the algorithm, then you're going to initialize the parameters, then randomly select an initial solution, set the current and best solution to the initial solution, find a set of neighbors so that the current solution will be attached, agreed. If the current solution has been figured out based on the neighbors, set of neighbors, calculate the objective function up to the each neighbor in the set and find the best among them. If the best neighbor is found, then the AV has been satisfied. That is, aviation value has been satisfied. If no, then again every and schedule is next in the next operation. If it is going to perform, then it is well and good. Else, stop the criteria which is not by satisfying the criteria. If the criteria is satisfied, then it is stopped. If no, then I'll go back to the set of neighbors to find the correct solution. Again, the current solution will be initiated and it will be started again. So that is how the taboo search will take place. Now next comes the fuzzy logic. Fuzzy logic is known from years altogether. It's nothing new. We are functioning. So we all know about this long back, not the fuzzy logic is nothing new a concept, as I have mentioned now. So it has been so that what is actually required over here. So the conditions are the main things which you are going to consider. For the cold state value, which is assigned as 0, and for hot state value as 1, then the vagueness will arises from the warm state, where it is in between the states of cold and hot. So concepts which are involving the fuzziness often difficult to model. So I can say the system has uncertainties in either the input or the definition. Mathematical models of any process does not exist, or difficult to model or too complex to evaluate fast enough for real-time operations, or it is too costly in order to design. So where you find that this operation in real time is very costly to design, there you can adopt this fuzzy models. So where you can say where you can say the you're going to have some medium in between operations also. So that is like, for example, cold, hot, and warm. So which lies between 0 and 1 state. And similar fashion, the around 80 degrees bigger than 25 degrees, fuzzy number, right? Then the singletons like male, female, dead, and alive, neither flexibility nor intervals. So fuzzy sets is a continuous set which lies between 0 to 1 or red to yellow conversions. So it is how the fuzzy linguistic terms will be given as a beautiful lady, good quality, and so on. So characteristic function of fuzzy term will depend on the control variables, defuzzification, overlap, solution fuzzy set, solution variable, and fuzzy model. So what do you mean by control variable? Control variable is nothing but state of solution of that particular variable. Based on those variables, how you are achieving that particular solution. Okay, it is not the complete solution, but subset solutions where it can even go for further process. So defuzzification is nothing but converting an output fuzzy set into a single value. So the subset value of solutions which you are arriving can be derived further in order to have one single solution. So overlaps will be removed. One domain of fuzzy set overlaps with the other, so those overlaps need to be considered. So that these, for example, there are some 4 different sub problems you have identified and 4 different solutions. In that you have identified first and fourth have the similar solution. So in that case, those are the overlaps of that particular set. So solution fuzzy set can be created using the fuzzy models or based on the current variables which are being derived. Then based on the variables, you are going to consider the fuzzy logic system, which is meant to be fine. Then the fuzzy system that converts input into their fuzzy representations. There are 4 steps that need to be followed in order to design the fuzzy model. The first step is to define the model function and operation characteristics. That is, which function you are going to consider, what kind of operations you require in order to have that function, have that objective need to be achieved. Okay, based on a set of functions and operations. The second step is to have control surfaces, which is using given R concepts. Okay, a set of concepts might be existing. In order to have the control surfaces, you will be giving some conditions based on this. This can be applicable, this can be applicable. So in order to solve one problem, we can have different set of solutions and we can solve it in a different way. So a label is meant to be created associated with the variable, which is an odd number. Okay, the label should overlap with the each label will overlap with 10 to 50% with the neighborhood for smooth, stable, fuzzy control surface. So the density of the fuzzy should be highest around the optimal control. So the once we achieve this local label, which is meant to have the odd number, and the each label which is overlapping with the neighborhood, and the density of that fuzzy with the highest optimal control, Once we achieve these conditions, then we are moving towards the third step, where you are going to say the control of that entire behavior, control behavior of the entire function which we have mentioned above. Then the fourth step is to have a defuzzification. That is, you are going to calculate the composite maximum and the concentration of that particular function. Then the fifth step, you are going to receive the fuzzy sets and the membership. Then sixth step involves the fuzzy membership functions. So I can say this membership functions consist of a control fuzzy variable, which is where the capital X of that particular subset belongs to the capital X, where the capital X will be the graphical set of objects, which is actually then derive the membership from of the X from the capital X, where we can say that if X belongs to A or X belongs to 1 or 0. Where it is called as a valuation set, A is called the fuzzy set. So which is closer to 1 or which is closer to 0, which we are going to define. So this is the fuzzy optimization function. And in real time, if you consider these things, I can say your ideally not the club memberships, your students will get into interact. So although they belong to the department of your computer science, IT, and so on and so forth, so but still they belong to some club as a club members and they do some work there. So those club members are also, I mean, once they register to, for example, we have in NITK, we have 26 clubs. All those students belongs to IT department of NITK, that is small x to the capital X, which has been mapped. And once they are mapped, then they are part of any club membership, that is mu of A. And once they obtain that membership, they should able to perform the operations with respect to that membership in order to get the degree from that particular club, and that whatever the score they are going to obtain from that club will be mapped to their memo, that is in terms of credits in the final consolidated memo will be given, which will be given to them. So in that way, I can say the entire control step, the first step to the entire operations where they are introduced, they are interested, then whether there is an overlap. Because see, one thing is, if they are to a club members of IT related clubs, then it is easy. There will be overlap for the projects, for even to have a stabilization of that students, and they will stay for entire 3 years as a club members. If the IT students are selecting the club member to be a club member of mechanical based club, then it is very difficult. There won't be any overlap, and with the neighborhood connectivity will be lost. So for that reason, we say that this fuzzy optimization, we can, I mean, this is one example which I've considered. Similar examples you can consider according to your requirement. So these are some of the examples, and these are the techniques which we have come across. There are a lot of other algorithms which are existing. I'm not saying that these are the only algorithms which are existing. There are a lot of algorithms which are existing with respect to this optimization techniques. You can even go through them. And application with respect to mechanical varies. This optimization definition also, as well as the application, will vary with respect to mechanical in a different way, to the civil in a different way, and to the IT department or computer science elective, the circuit branches, it differs in a different way, where they are applying the algorithms, where they're achieving some kind of outputs in a different way in order to execute some programs and in order to get some outputs. Okay, so it matters a lot when it goes from department to department, the optimization techniques, how you are applying. Although algorithms look very similar, but when you go in a practical application, it differs from one department to to the other department, because the inputs what they give is completely different to the other department inputs. So this is how the membership I have taken the example. So this is for the today's discussion with respect to optimization methods or techniques, I can say. Not only these are the very famous algorithms which we have discussed as of now, and there are many other algorithms which exist where you can combine with some of the ML algorithms, some of the DML algorithms, because these all again deal with your neural networks and other stuff. And coming to quantum machine learning and quantum deep learning, which I have worked as this entire uh, workshop is based on AI/ML. So I'm just taking a small glance of giving a glimpse of quantum machine learning and quantum deep learning. So we have worked with the quantum deep learning where we have detected the deepfake detection. So that is one of the part where it has given us positive output when we have used quicker. The performance was very fast when compared to the classical MLDL algorithms. So quantum KNN is available, quantum SVM is available, quantum QSVM, sorry, quantum not fuzzy logic, KNN SVM logistic regression is there. So all these are, we use the existing algorithms and we compare the algorithms, even quantum CNN, quantum KNN, so on and so forth, whatever algorithms are there. Even some ML algorithms are also existing. Even we have used for text data sets, and we have retrieved that these algorithms can be used if once the servers are installed with, like how you have this Python programming for the MLDL, Python ML algorithms readily available. If such kind of algorithms are made available for quantum also, then the ML, whatever the ML is taking around 2 days in order to achieve your output, it can be done fraction of second using the quantum ML algorithms. So that is what we have even derived. We have not worked with ML, we have directly worked with the DL algorithms for the deepfake image and video detections. So in that scenario, when we have experimented, as it was a huge data set, around 4 GB to 400 GB we have considered. Although we have considered that much data, still it could able to retrieve the information within 1 day. So although we don't have the quantum systems right now, and not a set of, I can say, not a set of servers which are existing only to run the quantum machine learning and quantum deep learning algorithms. Okay, so still, although it is not available, but it is a drastic time-saving process which we have observed. Now I'm open for the discussions. So there is some internet issue in between. I'm unable to. I just now I saw that that whatever I'm speaking also I'm unable to. I mean, you people were unable to get it because we lost the connection. Sorry for that. Till now I just discussed about the deepfake detection in detail, like which algorithm where you can replace converting of the classical text data into the quantum data, then feeding it to the quantum learning algorithms, deep learning or machine learning, whichever you feel. So the classical data as it is, if you give, then it will not work out. So you have to convert them into quantum data. Some variational circuits and all other stuff is readily available, so that you can consider and you can proceed for the further process. So this is one way of to getting introduced to the new environment, emerging area, I can say. And because that is also part of artificial intelligence. So this also you can continue. So any queries from your end? Very good. Please, any feedback from your end? Any suggestions or feedbacks? So this is from my end. The discussion ends right now. From my end, whatever I discussed just now. So if you have any queries from your end, you can, the discussion which I have discussed with respect to deepfake detection just now. So this ends my way of your presentation and why we are adopting this quantum machine learning and deep learning for this and all. I'm winding up right now. Queries are welcomed from your end, right, from now onwards. So if any queries are there, please let me know, else we can wind up the session.
If if anybody is having any sorts of queries, please feel free to ask, ma'am.
Kiran sir, Actually, there is some disconnectivity also which is happening. Internet is getting disconnected. So anybody have raised any query? Sorry, I lost the connection.
Not until now.
Hello,
Well,
sir, your voice is not audible. Hello,
is it is it audible right now?
but there is a break, sir. Maybe internet because here it is heavy raining. So maybe because of that internet issue is there. Yeah, please can you let me know if any queries they have raised or asked because I'm unable to hear it.
No, ma'am. No queries were
Okay,
raised until now.
okay, okay. Then I guess we can wind up the session if no more queries
Uh,
because I have done my part.
Thank you so much, ma'am, for the knowledgeable presentation that you presented to us. It was both insightful and engaging, and it is truly enriched with the knowledge of everyone who has attended. And we look forward to having more such sessions with you. Uh, uh, and we are really thankful for thankful to you for coming into the session and giving your valuable insights on this topic. Thank you very
Thank you,
much.
sir. Thank you.
Sir, the feedback forms will be shared in the feedback forms will be shared with everyone in the WhatsApp audience, and also it will be shared in the YouTube live. Thank you very much. The afternoon session will be starting by 2, and we request all participants to join the meeting by 1:30 so that it goes on smooth.